Good morning, Algebra kids. You guys have almost made it. You almost got through your first year of algebra, and you only have about a couple more days left. It's gonna be summertime, and you're gonna be off to high school. So let's go ahead and let's get through the last couple of lessons together smoothly, and then I'm gonna tearfully send you guys off into high school, and I'm gonna miss every single one of you dearly. But with that being said, let's go ahead and start with Chapter 10, Lesson 3. We're continuing with those radicals. This is going to be operations with radicals. And any time you think different operations, we're thinking addition, subtraction, multiplication, and division. So we're going to be working on those 4 operations today, all with radicals. Now we've got, I believe, 9 problems today, so not too many. Stay with me, get these copied into your notebooks, and then after the video is over with, you can go outside and hopefully enjoy a nice day today. So let's get started. Now, before we begin solving any of these problems, we need to know the difference between like radicals and unlike radicals. I like to think of these in the same stance as variables. So for example, like radicals. Well, if I had 3 radical 5, that would be the same thing as 7 radical 5. Those would be like radicals. And they're like because the number that's inside the radical is the same. It's a 5 on both. It's the same thing if I had, for example, 3x and 7x. They both deal with an x, so therefore I can combine them. These would be what we consider like terms. Same thing with these radicals. Because the radical is the same, it's radical 5 for both, then we can combine those. Another example, if I had 2 radical 7 and 4 radical 7, those would be like. Their radical is the same, they're both radical 7, so I can therefore combine those. On the flip side, if I had unlike radicals, say here I had 4 radical 3 and 2 radical 2. Well, what's underneath the radical is not the same. On the left-hand side we have a 3, and on the right-hand side we have a 2. Those are unlike, so I cannot combine anything that looks like this. So, cannot combine. So there's not a whole lot you can do, guys, with ones that are unlike. And again, I like to think of these in terms of variables as well. So if I had 4x and 2y, every one of you guys should know you cannot combine an x with a y. So this would be as far as I can go with it. And just kind of another example here, if I had 5 radical 1 and 5 radical 3. Again, radical 1, radical 3, not the same. It would again be like an x and a y. They're not identical, so I cannot combine those 2 radicals then. Let's kind of work ourselves into some problems. So I think addition and subtraction, guys, are going to be the simplest. So if I look at number 1 here, I have 6 radical 11 plus 9 radical 11. Now, before I get started with this one, what if I were to give you 6x plus 9x? Well, you would be, Mr. Garrett, that's easy. I add my whole number, which happens to be 6 plus 9 is 15, and I leave my x, so it would be 15x. Well, the same thing is true with radicals. I'm going to add my whole number, and then that base, which happens to be the radical and whatever number is underneath the radical, that's going to stay the same, just like with my x values. So 6x and 9x, combine those 2, and I left it with the x. So my answer for this would be 6 plus 9, again, 15, and then having that base, or the radical in this instance. So my final answer would be 15 radical 11. So guys, we're just combining what's on the outside, and then whatever is underneath the radical, we're going to leave alone. Again, very similar to what we do with variables. Let's look at number 2. This time I've got 7 radical 2 minus 8 radical 2. Again, radicals are the same. Both are radical 2. I'm just subtracting here, so I'm going to subtract what's out front. So 7 minus 8. That's going to give me -1. And what's my radical? My radical is -2. So my final answer on this one would be -1 radical 2. And if you want a simpler way of maybe writing this one, the -1 can be a little redundant. It's the same instance, guys. Say I replace this radical 2 with an x. We don't ever write things as -1x. We always just write them as -x. So I can actually do the exact same thing with radicals as well. So another way of writing this would just be negative radical 2. But both of those answers would be acceptable. So there you go. If we're adding and subtracting with like radicals, that's how we would solve those. Let's look at number 3. On this one, I've got 5 radical 3 minus radical 12. Well, already off the bat, you should be looking at these saying radical 3, radical 12, those are unlike. Yes, they are unlike. However, I can simplify one of them. So we need to be looking ahead and looking, okay, can I simplify one of my radicals? My general rule of thumb, guys, if it's a prime number, such as 11, such as 2, such as 7, such as 5, such as 3, if it's a prime number, or 3 again here, if it's a prime number underneath the radical, it's as simplified as it can go. You cannot simplify it anymore. 12 is not prime. I can break 12 apart. So I need to break radical 12 apart, and I need to simplify this. And again, when we simplify radicals, I'm looking to simplify it into a perfect square. So I know that this can break apart into radical 4 times radical 3. Because 4 times 3 is equal to 12. And I also know that radical 4 is a perfect square. I'm going to simplify this radical 4. When I simplify that, that gives me 2 because the square root of 4 is 2. So I have 2 radical 3. And then I'm going to write the rest of my problem here. So I have 5 radical 3 minus 2 radical 3. And now I have like bases. So now I can solve this problem. Radical 3 on both of these. So I just do 5 minus 2. 5 minus 2 is 3. Then I'm going to add on that radical. So 3 radical 3. And that's going to end up being my final answer here. So that's as simplified as it can go. I've got a prime number underneath my radical. I've combined my like terms, as you could call them. So 3 radical 3 is your final answer. Let's look at number 4. This one is very similar to number 3, and I think this would be a good spot to pause the video, maybe try it out on your own, and see if you kind of got the hang of it. Because what we did over here with this radical 12, guys, we did that last week, so you should be somewhat familiar with that step already. Now, let's go through and let's solve it. So I've got 4 radical 7 plus 2 radical 28. Again, not like bases, not like radicals here. One's a 7 and one's a 28. So I cannot just add these two together the way that we see them. However, 4 radical 7 is as low as it can go. 7's a prime number. I cannot divide it and split 7 up into two numbers. However, I can split 28 up. What can I split 28 up? That needs to be my next question. And again, I'm looking for a number, a factor of 28, that's a perfect square. So if you were to list off, as kind of a refresher to last week, your factors of 28, okay, 1 and 28. Neither of those are perfect squares. What if I have 2 and 14? Okay, neither one of those are perfect squares. I could do that, but I'm not really getting anywhere. What about 3? Well, 3 doesn't go into it. What about 4? Okay, so 4 times 7. Those are two factors of 28. Are one of those a perfect square? The answer is yes. Well, which one is it? 4 happens to be a perfect square. So this set of numbers is going to work here. So I'm going to rewrite this as 2 radical 4 times radical 7. Then from there, let's simplify this now. So 2 times, what is radical 4 simplified as? 2. So 2 times 2 times radical 7. Let's go through and let's simplify this whole thing out now. 2 times 2 is 4. 4 radical 7. So I'm going to have my new problem as 4 radical 7 plus 4 radical 7. I go through, I simplify. 4 plus 4 is going to give me 8. And I can go ahead and add because both of these have the same base. They both have this radical 7 as their base. So 8, and then my radical is going to be that radical 7. 8 radical 7 is my final answer. All right, so that's going to kind of wrap up, guys, the whole addition and subtraction section. Make sure that you are simplifying and make sure that you're really looking at all your problems and kind of going from there. Now, I didn't cover this, but if I had two, here, we can do a problem real quick with it. We'll call this like 4b. Okay, for 4b, if I had 2 radical 3 plus 3 radical 5. Notice, not like bases here, 3 and 5. Can you simplify either of these? No, you can't simplify these because one's a 3 and one's a 5. Guys, if you get any problem like this for your, just kind of in the future, I'm going to tell you right now, for me, in our algebra class, leave it blank or just put no solution because we haven't gotten into anything like this yet. This is not part of Chapter 10, Lesson 3. You cannot simplify this into two numbers with like bases, okay? One's got a base of a radical 3, one is a base of a radical 5, so you can't really do anything with this problem, okay? So that's what separates this problem from these other 4 that we've already completed. Let's go ahead and let's move into number 5. So again, I told you we had 9 problems. We're already on number 5, so we're making good pace. Number 5, this time I have radical 10 times the quantity radical 6 plus 3. Now this problem should look like one of the properties that we've covered now for the last couple of years, and that is the distributive property. So you're going to distribute this radical 10 inside of the parentheses, and whenever we distribute, we do multiplication. So I'm going to end up multiplying this all out. Now, when I do 2 radicals and we multiply these, it's just like when I did this radical 4 times radical 3 equals radical 12. You're just multiplying the numbers underneath and you're still leaving that square root symbol above them. So 10 times 6 is equal to 60, and I'm still leaving the radical with it, plus, now I've got a whole number and I've got then a radical 10. So it's going to be 3 times radical 10. Now, my problem is very similar to what we did on 1, 2, 3, and 4. So again, whenever we have to distribute, we're just simply multiplying that whatever is on the outside by the quantity on the inside. Now I need to break this apart. I can simplify radical 60. So let's go ahead and let's simplify radical 60. What could we break radical 60 into? Again, I'm thinking perfect square. I'm thinking what can I divide it by? What factors? And guys, if it helps, write your factors out. So 1 and 60, that's my first set of factors. I'm going to tell you right now, on your set of factors, guys, the one that is itself in 1, this one's really not going to help you a whole lot. But visually, if it helps to see it, write it down. We start going through them. My next set is going to be 2, 30. Okay? Again, 2 factors, but neither are perfect squares, so it doesn't really help me out a whole lot. I can divide it by 3. 3 and 20. 20. Not a perfect square, so that really doesn't help me out much either. What about 4 and 15? Well, hey, 4 is a perfect square. So 4 and 15 are going to work. Now, we could have kept this going, guys, and said, okay, 5 and what? 5 and 12. Well, neither are perfect squares, so let's keep going. What about then 6 and 10? Neither are perfect squares. Okay, but notice we're kind of getting now into some extra work. I've already found a set of factors here where one of the numbers is a perfect square. When you get to that point, I would probably just stop and use that set of factors then. So when I simplify 60, it's going to simplify into 4 times radical 15. I simplify radical 4, that's going to give me 2 radical 15. Now let's continue writing out the rest of this. Plus 3 radical 10. Okay, from here, we already know the left side of this is as far down as we can go. We know it's as far down as we can go because if I look at the number 15, when I think about my factors of 15, 1 and 15, 3 and 5, that's it. There is not a single perfect square here in my factors. So I know the left side, 2 radical 15, that's as low as it can go. What about 3 radical 10? Is that number as low as it can go? And the answer is yes as well, because my factors here, 1 and 10, 2 and 5. Again, I don't have a perfect square. So this is as far as I can go. 2 radical 15 plus 3 radical 10. So that is indeed my final answer here. It's okay, guys, if you get a problem, you've simplified it, and you still have an addition symbol or a subtraction in the middle. This is okay. The same thing, guys, if you had a problem that was, okay, 3x plus 2x plus 3y. On this problem here, I combine my x's, that gives me 5x plus 3y. Well, I can't take this problem down any further because one has an x and one has a y. It's the same scenario here. Radical 15, radical 10, I can't combine those two. However, this final answer is simplified compared to anything above it. So go through and simplify. This is okay though. So this would actually be your final answer for number 5. All right, let's move ahead to number 6. This time I've got 2 sets of quantities, 2 parentheses. Your one on the left reads radical 6 minus 2 radical 3. The one on the right reads radical 6 plus radical 3. This should look very familiar to you. There was a certain acronym that we used to solve these types of problems, and hopefully you remember it and you haven't forgot it. We called this FOIL. We did, anytime we had 2 sets of parentheses, we multiplied these out. We multiplied the first, we multiplied the outside, we multiplied the inside, and then we multiplied the last. And that's what the FOIL stood for, first, outer, inner, last. So whenever we have 2 sets of parentheses, we still solve these the same way and in the same manner. So first, radical 6 times radical 6. Radical 36. Now, I know in my head looking at this, radical 36 can be simplified. I'm not going to simplify it just yet. I'm going to go ahead and multiply this whole thing out. So do your FOIL, your first, outer, inner, last, before you begin to start simplifying, okay? Just to kind of make these steps a little easier on you. Now do your outside. So radical 6 plus radical 3. And that's going to give me positive radical 18. Now let's work on the inside. So I've got negative 2 radical 3 times radical 6. That's going to give me a minus 2 radical 18. And your final, minus 2 radical 3 plus radical 3. Minus 2 radical 9. Now, from here, let's go ahead and let's simplify. Now, I'm going to pick some of the easier ones first to simplify. Radical 36. Radical 36, what is the square root of 36? That is 6. So 6 plus square root of 18 minus 2 square root of 18. Now let's look at our last number here. 2 radical 9. Well, what is the square root of 9? So minus 2 times 3. Square root of 9 is 3. So we're kind of breaking this apart and we're able to simplify it a little bit. So 6 plus radical 18 minus 2 radical 18 minus 6. All right. What about 6 minus 6? 6 minus 6, I combine my whole numbers. That's going to give me what? 0. So those actually cancel out. So now let's focus on the inside. I've got positive radical 18 minus 2 radical 18. Should notice I don't really have to simplify here. Radical 18, like bases. So this is like having a plus 1. So plus 1 minus 2. I simplify, I'm going to get negative 3. Sorry, Mr. Garrett's jumping the gun a little bit. I'm looking at the answer too far ahead. When you do enough of these, you can kind of see the end of it. Positive 1 minus 2. Plus 1 minus 2, you get negative 1 radical 18. Now, I've got this down to negative 1 radical 18. Go through, simplify your radical 18. You can simplify it. So I'm going to break this apart into negative 1 times radical 9 times radical 2. And the reason I chose 9 and 2 is because I know that 9 is a perfect square. You could have looked at other factors like 6 and 3, but 6 and 3 are not perfect squares. Okay, let's simplify it. So the square root of 9, that's going to give me 3. So 3 times negative 1, there's your negative 3 times radical 2. So negative 3 radical 2. And there is your your final answer. A lot of work on that one, guys. There's kind of a lot visually to see. These outer steps, guys, were not the ones that you had to do first necessarily. You could have started working on the inside and combining your like bases here, those like radicals of radical 18. It really didn't matter. I kind of like working with the whole numbers first, though. So that's why I kind of worked on the outside and then kind of worked my way in. But there and again, being able to simplify and look ahead that, hey, like bases, I can combine those. Whole numbers, I can combine those. And that then got me to my final answer of negative 3 radical 2. All right, let's go ahead and let's look at one more problem on this page before I turn over. So number 7 out of 9, we're almost there. I've got radical 11 minus 2. And guys, I've got that quantity squared. Now, we cannot just square the first and square the last here, because then we're kind of forgetting about those middle terms. So my best advice on these is going to be, because we're dealing with radicals, because these are new to us, and so that we're not really forgetting any step in the process, I would write out what that actually means. And that means radical 11 minus 2 times itself. And then from there, complete FOIL. Do first, outer, inner, last, and go through those steps. It might take you 30 extra seconds to go through and do it this way, but I'd rather get this problem right, especially with radicals being new to us. We have not messed with them this year all that often. So let's go through and let's solve. So my first, radical 11 times radical 11, square root of 121. And this is where I wish we were in class, because I think some of you would already have started to catch on to a theme here with this FOIL. Let's go ahead and let's move on. So outer, negative radical 11 times negative 2 minus 2 radical 11. I do the inside, so minus 2 radical 11 And last, radical negative 2 times negative 2. That's going to be a positive 4. All right, let's go through and look at this. Radical 121. The square root of 121 is equal to 11. Well, if you notice, guys, on the last two problems, I started with a radical times a radical, same number, and it came out to be that number without the radical. So what do you know? Radical 11 times radical 11 is 11. Same thing up here. Radical 6 times radical 6 is equal to 6. So kind of pick up on some of those tricks, and being able to see some of these problems will really kind of help you out when you solve them. So I've got 11, and then let's go ahead and let's write the rest of this out. Minus 2 radical 11 minus 2 radical 11 plus 4. I'm going to go through and combine my whole numbers next. Again, I like whole numbers, so I'm going to do those first. 11 plus 4, that's going to be equal to 15. So I've got 15 minus 2 radical 11 minus 2 radical 11. Now I've got some like bases. I've got some like radicals. That like radical is radical 11. So I can combine these two. So when I combine them, negative 2 minus 2 is equal to minus 4. Now I'm going to write that radical of 11. And that's actually going to be my final answer here. 15 minus 4 radical 11. And that's because that 11 is a prime number. I can't break it up. I can't simplify and go any further, any smaller. So there you have it. Those are the first 7 problems, guys. A look into this chapter. We've got some adding, some subtracting. We've done some distributing. And we've also done some FOIL as well. Now, let's get in. We've got 2 problems left, and then we will wrap up today's lesson. Now, before we get started with number 8, I want to look at a vocab term, and that is called the conjugate. And the conjugate is the sum and difference of the same 2 terms. I'm going to show you what that means here on number 8. So on number 8, I've got a fraction, and that fraction is 10 in the numerator, and then in the denominator, it's radical 7 minus radical 2. Remember, whenever we were solving radicals, I always said you cannot have a radical in the denominator. So we need to get rid of that denominator that's in the, we need to get rid of the radical that's in the denominator. Now, radical 7 minus radical 2. I can't do anything with this denominator because they're both in lowest term. They cannot be simplified. Both are prime numbers. They're not like bases, so I can't combine them. So how can I get rid of them? The way to get rid of them is with what we call this conjugate. I'm going to, very similar like we did in our last lesson, I'm going to multiply to get rid of my denominator here. When I multiply, I'm going to have to pay attention to my denominator. So I'm going to multiply this by this radical 7 and this radical 2. Notice the conjugate is the sum and difference of the same 2 terms. So I'm going to multiply now, because this is subtraction, by the opposite, which is addition. So I'm actually multiplying, guys, by radical 7 plus radical 2. If this had happened to be an addition symbol, then this sign would have been subtraction. That's what the conjugate is. And the way I think of it is, it's almost like the opposite. Whatever the one is, you're going to do the other. So if this, again, if this were addition, we would have done subtraction over here. But because this is subtraction, that's why we're multiplying by positive. We're just taking this denominator, we're multiplying by it with the numerator and the denominator in the new fraction, and it's just a completely different sign. It's just the opposite sign. Now, whenever we multiply by the conjugate, again, when we multiply fractions, we multiply straight across. So when I multiply this here, I'm going to be left with 10 times the quantity of radical 7 plus radical 2. So that's my new numerator. Let's look at my denominator here. you've got radical 7 times radical 7. Well, remember, when we did radicals times radicals, guys, it was what was underneath, as long as they were the same. So I've got 7 times 7. They're both under the radicals, so that's actually going to come out to be just a 7. Same thing, 2 times 2, both underneath the radicals, so that's going to come out to just be a regular 2. Now the sign in the middle. The sign in the middle is going to stay the same as the sign that we started with. So it's going to end up as 7 minus 2. So kind of a shortcut with your conjugates. You're multiplying by the denominator with the opposite sign. That's how I produce this numerator. The denominator is simply taking the denominator with your radicals, you're getting rid of the radicals, and the sign stays the same. So that's really what we're doing with the conjugate. If you want to see it, guys, then come out on the side, maybe after this video is over with, and do 7 minus 2, both radicals, times the quantity, radical 7 plus radical 2. And when you do FOIL on these, you're going to find, here, we can do it real quick. Radical 7 times radical 7. That is radical 49. You take the square root of 49. That's 7. Do the outside. Plus 2 radical 7. Do the inside. Minus 2 radical 7. Do last. 2, 2. When I multiply those, I get radical 4. Well, what is radical 4? Radical 4 is 2 minus 2. And the reason it's minus is because 1 is subtraction, 1's addition. When I multiply addition and subtraction, I get subtraction. So now let's go through this. Plus 2 radical 7 minus 2 radical 7. Guys, that's the same thing as having plus 2x minus 2x. Well, what is positive 2x minus 2x? They cancel. That creates 0. So what I'm left with is 7 plus minus 2. So you get rid of this plus that goes with the 2 radical 7. You're left with 7 minus 2, which that's my new denominator. So that's why this makes sense in how whenever I do the conjugate, my new denominator, it's simply what my denominator was minus the radicals, sign stays the same. So that's kind of why that makes sense with it. Now, if you feel more comfortable, multiply straight across. Do FOIL to find out what your denominator is. Multiply straight across to find out what your numerator is. Because all I'm going to do next here is I'm going to do the distributive property just like we did on number 3. I would much rather see you guys go through and do FOIL and work this entire thing out to see you get it right than to see you mess up with this denominator and numerator action and completely botch this problem, okay? So that's enough on it. Let's go ahead and let's finish this problem out. So I need to simplify both my numerator and my denominator. So let's take this 10 and let's distribute it into both. So when I distribute it into both, I'm going to get 10 radical 7 plus 10 radical 2. And on the denominator, I'm doing 7 minus 2, which is 5. Now I'm going to go through and I'm going to simplify. Now, I can simplify through division here. 10 divided by 5 and 10 divided by 5. When I take 10 divided by 5, that's going to be 2. That's 1. That's 2. That's 1. So when I simplify this, I get 2 radical 7 plus 2 radical 2. Another way of maybe seeing this, how I got the 2 in front, leave your numerator the way it is here. So have 10. On this step here, you could have done, guys, 10 times the quantity radical 7 plus radical 2 and put it over 5. and then say, okay, 10 divided by 5 is 2 over 1, and then distribute that 2 in. And when you distribute the 2 in, that's how you end up with 2 radical 7 plus 2 radical 2. I cannot go further than this. I'm sure you're probably getting sick and tired of listening to that. 7 and 2, both prime, so what's underneath the radical you can't go any further than. So that's your final answer. Can't combine them because one is not like bases. So there you go. 2 radical 7 plus 2 radical 2. Final answer. All right, guys, you made it. Last problem in the video. Let's look at number 9. So with number 9, I've got 1 plus radical 5 over 2, and that's equal to 4 over w. To solve this problem, solve using a proportion. Mr. Garrett loves proportions. It's one of his favorite math problems. Proportions. Cross multiply. So we're bringing that back into the game. Multiply what's crossing. So 2 and 4, that's going to be equal to, and I multiply 8. Have that equal to w. What am I multiplying w by? Multiplying it by this numerator here of 1 plus radical 5. So in order to solve this, I need to then distribute. 8 is equal to w times 1 is w. W times radical 5 is equal to w radical 5. I think we can all probably get to that point right there. But when we get to this point right here, what happened? We now went from having one W to now we have two W's. I've got W, and I also have W radical 5. I don't want to make more W's. I want to find out what W is equal to. That's the point of solving a proportion. That's the point of having a variable in a problem. I want to know what does that variable equal. So this step here, don't do it. That's going to be the number one mistake that you guys are going to make. I'm going to tell you right now, I know for a fact it will because we've done distribution in this lesson. There are times to distribute and there are times not to. And the times not to are when there is a variable in play. I want to know what that variable equals. Don't make more variables, make fewer. I want to know what it equals. So I want to get that variable by itself. So if they're being multiplied here, how can I make W by itself? I can divide it by what it's being multiplied by. So divide the entire thing by 1 plus radical 5. So I'm going to rewrite this, make it a little prettier, a little easier to see. 1 plus radical 5 is equal to W. Now we can solve. And now this problem became just like number 8, where we solved with the conjugate. We solved by finding, now we can get rid of the radicals in the denominators. So again, I'm going to kind of rewrite this because I like to work this way with my conjugates. So 8 over 1 plus radical 5. I'm going to multiply by the conjugate. Now, again, I'm taking my denominator, 1 radical 5, 1 radical 5. What's my sign? It's positive here, so it's going to be subtraction here. So now let's go through. So 8 times the quantity 1 minus radical 5, and then my denominator. Remember, we're taking what it was, so 1 radical 5. We're getting rid of the radicals, so 1, and now just 5. And we're taking that sign, and that sign is going to be, this time, subtraction. Oh, there we go. This sign And excuse what I said on number 8. This sign, guys, is always going to be subtraction. So, again, I know what I said on the 8. Sign is always going to be subtraction. And again, that's because we're foiling this 1 plus radical 5 and this 1 minus radical 5. Now let's go through and let's simplify this one. So I'm going to have 8 times 1, 8, minus 8 radical 5 over 1 minus 5. Well, what do you get when you do 1 minus 5? You get negative 4. So now let's go through and let's simplify this. 8 divided by negative 4. That gives you negative 2. Negative 8 divided by negative 4. That's going to give you positive 2 radical 5. So, what is W equal to? W is equal to negative 2 plus 2 radical 5. And we should probably put W is equal to that. Now, when you guys get to the point and you're solving these problems and maybe they want an actual numeric value for W, a couple ways you can do it. If I were grading them, I'm fine with this answer because this answer cannot be simplified any further. However, if they want an actual value for it, type it in and you can get a value for it. So if I take this problem, I do negative 2 plus 2 radical 5. So I type it in just how my answer is and I hit enter. My calculator is going to give me a value for it. And that comes out to be 2 point, if we round, we'll say 2.5. So W could equal that expression, or it could equal about 2.5. So there you go. A couple ways that you could kind of have an answer for that one. But guys, what we've done today is very similar all in all. Conjugate, again, denominator, always subtraction. But conjugate, we had distributive property, we had addition, we had subtraction. And we also kind of, again, with the proportions and with the variables. Don't make more variables, make fewer. Guys, I hope you enjoyed the video. I'm missing every single one of you. I hope you guys have a great rest of the day. Bye.